Good day, friends. Welcome to the last session of Unit 5. The session is about titration of a standard solution of sodium hydroxide against a mixture of phosphoric acid and hydrochloric acid. Here we are going to use the discontinuous method to determine the concentrations of phosphoric acid and hydrochloric acid in a mixture. Let's look at the objective for the session. By the end of this session, you should be able to determine the concentrations of phosphoric acid and hydrochloric acid in a mixture using the discontinuous method. In the previous session, we used the continuous method. Okay, so here is the problem. Almost like the previous session, but just that here we are using the discontinuous method. A is a solution containing unknown concentrations of phosphoric acid and hydrochloric acid, and B is 0.2 moles per dm cubed sodium hydroxide. So we have to perform this. It's a discontinuous titration, and from the data we have to calculate the concentrations of phosphoric acid and hydrochloric acid, and we have to take the volume of sodium hydroxide at meter orange endpoint to be 9.8, and that of the phenolphthalein to be 15.30. Double indicator titration questions are easy to solve once you're able to establish the volumes of the burette content used. Okay, let the average volume of sodium hydroxide at meter orange endpoint be V1 and at the phenolphthalein endpoint be V2. At the meter orange endpoint, we will have the whole of the hydrochloric acid being neutralized and 1/3 of the phosphoric acid being neutralized. So the volume of the sodium hydroxide at this endpoint is the volume that was able to neutralize the whole of the hydrochloric acid and 1/3 of the phosphoric acid. This is a discontinuous method, and so in the second titration, we will still have the whole of the hydrochloric acid present, unlike that of the continuous, where once it is consumed at the first phase, it is not appearing here again. So here it is present, and at the start also, the whole of we will have phosphoric acid also present, but in the course of the reaction, 2/3 of it is being neutralized. So the volume of the base at this endpoint is the volume that was able to neutralize the whole of the hydrochloric acid and 2/3 of the phosphoric acid. Now, let's label this one as equation 2. How do we work these out for us to get our various volumes? We have to do some subtractions. We have to subtract 1 from equation 2. Now, in doing so, if we are to subtract equation 1 from equation 2, we will have the whole of this hydrochloric acid cancelling this hydrochloric acid. Then here we are subtracting 1/3 from 2/3, and we are going to have 1/3, and here is going to be V2 minus V1. Okay, so that is what we have done over here. So what do? We just have to multiply through by 3 to get rid of this here. It means that if we want the volume of sodium hydroxide that would completely neutralize the phosphoric acid, then we need 3 times the volume at the phenolphthalein endpoint minus volume at the meter orange endpoint. At this point, we can put in our values, and in doing so, we have 16.5 cubic centimeters. This is the volume of the base that will completely neutralize the phosphoric acid. Okay, we know the concentration of the base, so we will convert this one into moles and find the mole ratio. From the concentration, if 1000 cubic centimeters of the sodium hydroxide contains 0.2 moles, then this 16.5 that we have found or we have used will contain how many moles? It will contain 0.0033 moles. So this is the moles of the sodium hydroxide that reacted with the phosphoric acid. And so we can proceed to the equation of reaction. From this equation, 3 moles of sodium hydroxide are required to completely neutralize 1 mole of phosphoric acid. So the mole ratio is 3:1. So if 3 moles of sodium hydroxide requires 1 mole of phosphoric acid, then 0.0033 moles of sodium hydroxide will require 1/3 times 0.0033 moles of the phosphoric acid, and that gives us 0.0011 moles. So this is the moles of the phosphoric acid contained in that 10 cubic centimeters of the mixture that was used. So we have to find the moles that will be contained in 1000 cubic centimeters. So if 10 cubic centimeters of the phosphoric acid contains 0.0011 moles, then 1000 cubic centimeters will contain 0.11 mole per cubic decimeters of the phosphoric acid. So this is the amount concentration of the phosphoric acid. What is next? We have to find that of the hydrochloric acid. Okay, so here we need to do some substitution. We found that the 2/3 of the phosphoric acid is equal to V2, or 1/3 of the phosphoric acid is equal to V2 minus V1, and so we can come back here and then put this in place of 1/3 phosphoric acid, and and equate it to the V1. Alright, so when we do that and work it out, we have 2V1 minus V2. So this is the volume of the base that we need, or that completely neutralized the acid. We can put in the values of V1 and V2, and that gives us 4.3. So this 4.3 is the volume of the sodium hydroxide that completely neutralized the acid. We need to find the moles in this 4.3, and we do as we do usually, and we are going to get 0.00086 moles. So this is the moles of the base that reacted with the acid HCl. We proceed and write equation of reaction where the mole ratio is 1:1. So the moles of the HCl is also 0.00086. This is the moles contained in the 10 cubic centimeters of the mixture used. So if 10 contains this 0.00086 moles, then 1000 will contain what? It will contain 1000 times 0.00086 moles divided by 10, and that gives us 0.086 moles per cubic decimeters of the acid. So the amount concentration of the acid is 0.086 moles per cubic decimeters. My good friends, we are ending the session with this self-assessment question. Please try your hands on, try to solve it. We will meet again in the next session.